because they require a lot of data collection and number crunching. That's why we have the word costly on this. These are basically started by our friend Schuhart back in the 1920s. And a couple key things I wanted to emphasize on this. Number one is we're going to spend an entire evening talking about just control charts alone. And but I did want to mention a few of the advantages and disadvantages of control charts. So advantages are that they're a visual display of the process performance, that they're statistically based. You can do both attributes and variables. The biggest thing here is the, at least for me, what I call assignable cause. Or special cause. So what that is saying, just a quick review of this, a control chart has nothing to do with your specifications as an organization. It is just what the process is doing. Okay? Too many people get used to the word control, meaning they think that we're physically manhandling the process. Does that kind of make sense? So when you hear the word control, that doesn't mean that it is being limited at that moment. We're plotting this so that we're looking for a special cause. In other words, these control limits are set at 3 standard deviations. So if you remember looking at that chart up here, 99% of the time a process will land inside of that. So if you get an observation outside of the control limits, only means that that is a statistically rare event and it warrants further investigation. Okay? Now if you have 2 or 3 outside the control limits, that's becoming very, very rare, and you might want to shut down your process to fully understand that. So assignable causes, those can be things such as machine drift, tool wear out, material changes, things of that nature. But that is the biggest advantage of that. There's disadvantages to control charts. The first one of which is it's costly, frequently requires some math to determine those limits. Many control charts that you'll see are X-bar, which are sample means. Once again, you're doing some math on that. It's challenging for small shifts. The classic Schuhart X-bar chart is very good for detecting a significant shift. So if we shift up by, let's say that a machine stop is bumped, that will typically be visible on a control chart very quickly. But if it's a very subtle shift, like let's say that we're talking about a cutting tool that has lost one tooth, I mean, it may be almost imperceptible to you. A standard Schuhart chart will not catch that. You need to use what's called a Q-sum. We'll get into that later. So control charts are one of the 7 classic tools, and we'll spend more time on those later. Next one we're going to talk about is Pareto diagrams. We're going to do a little history lesson about this. It's named after the gentleman, we'll just say Pareto. I can't say his first name.
Bill Pareto.
Thank you. It's not that hard to say, is it? When you look at, let's just write up here so just so everyone else can enjoy that. Is it common for you, Jeff, to remember first names of?
Only for Mr. Pareto.
Okay. Just not good with.
That's actually
terrible.
For co-workers' names are.
Kids' names. Bill Pareto.
All right, so 80-20 rule, or 80% 20. Can anyone on this side of the room answer what this 80-20 rule means which order you put the 20s and 80s.
80% of your problems come from 20% of the parts.
All right, that's a good way to put it. So historically, Mr. Pareto theorized that 80% of the world's wealth was held by 20% of the people, I believe is the way that worked out. And so he applied it only to economics terms, but this gentleman, Geron, said that it should be universal, meaning that just what you said, that 80% of the problems come from 20% of the causes. So that's where the 80-20 applies to just about all kinds of industries and natural situations. And so what's interesting is that we should actually call it the Geron chart or diagram, because Joseph Geron was the first one to apply it for manufacturing. But the other subtle history lesson with this is that the cumulative, attempt to draw this again. So Pareto, you sort the most significant ones to the left. And then many times you'll see a curve that looks like that. And on the right axis, it'll represent 100% at the top. That kind of makes sense. So here's about our 80. So the use of the cumulative curve on that is actually due to a guy named Lorenz. So I know a lot of you are very concerned that when you start working on your quality tools, you want to properly attribute those to the people who came before you. And now you can rest tonight knowing the rest of the story, as Paul Harvey might say. All right, so the key thing I just want you to, here's a neat phrase for that, the vital few. So if we recognize that 80% of our improvement can be done by attacking 20% of the issues, if you only have 10 categories, by focusing on 2 areas, you can get rid of 80% of your problems. So that is a tremendous advantage, going back to our earlier comment about financial limitations in an organization. Okay, is everybody comfortable with how to create a Pareto chart? They're not too terribly difficult to do.
What are your units of the x-axis?
Defect types.
So X in this cat, I've seen the words like categories.
I mean, almost anything.
Right, so, and it's not, I would like to remove the idea that the X is a unit of measure. It's just,
Attribute?
right, so this would be like A, B, C. So the width along this is unitless, is that the right word?
It really is a category. For PCBAs, you could have collected process point, you could have defects, you could have defect code, you could have model point. You can have any sort of thing you're collecting a column for, basically in Excel, that has some sort of result behind it, become your category that you're putting across that axis.
Easiest way to remember it though is defect types. Was it torn? Was it small? Was it big? What are those major defect types that you record in your business? It's the easiest way.
Right, so for quality people, that's frequently the case, but I'm still going to leave it at general terms of category, just because you may look at, from a sales volume standpoint, you want to prioritize. So how that would work in a quality situation is, if you're in an organization, which part number should I focus on my defects first? You would go check which are my largest runners of quantity, and then from that, what defects. It's a subtle thing, but
Assembly number, customer.
right, you could prioritize by customer.
By region.
There are many ways to slice and dice that. All right, so scatter diagram, looking for a relationship. So you have your classic X and Y. The biggest thing I want to caution you about on the scatter diagrams is we're just looking for a relationship. We don't know yet whether it's a cause effect. It may be, and frequently the classic way to represent that is X is your independent variable, Y is your response. That's normally how it's presented. But the goal of a scatter plot is just to see, is there a relationship? So this is frequently I was going to make a statement and I'm going to retract it before I even say it. Nonetheless, frequently you have units of like one relationship might be for temperature at high school football games and number of cups of hot chocolate sold at the game. So in that case, as the temperature decreases, you may have a relationship that might look like that. So that is a negative relationship that as the X increases, the Y response decreases.
Minitab has a really neat version of this where you can have 10 or 12 different variables in a project, and it'll actually give you scatter diagrams based on how many variables you have, like 4 wide and 4 tall, so you can see all the different relationships and what's going on in your one measurement study. It's really easy to use.
Another thing to watch out for if you don't have Minitab is if you have a plot that basically sits this way, that would tell us that regardless of the change in temperature, we're going to sell the same number of cups of hot drink.
That may be true for coffee, because people don't drink coffee only because it's hot or cold, whereas hot chocolate probably is temperature sensitive.
I forgot about iced coffee. That almost completely derailed my thought process. That was remarkable. But oh, the other thing to watch out for is curvilinear relationships. Because if you were to take and right mouse click on this in Microsoft Excel, depending on how your data is centered here and fit a trend line, it's possible you could get a trend line that fits exactly across like that. So that's why it's good to plot the data and make your own observation of that, that hey, that's just a curvilinear relationship. Any questions about scatter plots? The one thing I was also going to say for Brian's sake is that frequently this is a continuous scale, but it is possible just for relationship purposes to you can put an either-or situation like registered Republicans, Democrats, and then plot that to see is there a relationship of number of voters. That's maybe an oversimplified case, but it does not have to be numeric to see if there's a graphical comparison to that.
The two examples I had that I thought were funny or interesting were if you plot number of police officers in a city versus amount of crime committed in a city, it'll give you an almost one-to-one direct relationship.
Is that in Chicago or
Any city. Any city. Because, and that would apply to you, you think there's some sort of relation between the number of police officers and the amount of crime committed, and going to your cause and effect statement. Just because there's that relationship where you have more police officers, there's more crime, doesn't mean that the relationship being strong causes causality.
Yes, if you want less crime, fire all your policemen.
Not gonna work.
Right, that would be what someone might read from that graph.
Yeah.
Well, there's some towns in South Dakota that don't have law enforcement in town.
Right.
They don't have any
Doesn't mean
people.
there's
Do
no
you have any
crime.
people? plenty of vigilantes, though, or at least gossipers. All right, so the next thing we're going to cover, that's the end of the 7 quality tools. Now we're going to do the 7 management tools. All right, so for myself, I have not really used these management tools. Have any of you used them in your work much? For Larson, have you guys dealt with these much? Or we're going to go through them anyway because I think there's value to them, and especially if you're intending on taking the exam, my exam as well, the CQE, it's helpful to know these terms. So we'll start with the affinity diagram. All right, so the best way I understood for this is to go through the steps. And that made sense to me. So you're going to define a problem. And then create either note cards or post-it notes. So then what you're going to do on each of these, on each note card or post-it, you're going to write a piece of data or information or some type of opinion on that. You're going to place all of these on the wall, hence the sticky part. If it's a note card, then you're going to do it on your table. And then you're looking for patterns. And then you're going to create groups off of that. And then you're going to get categories. All right, so I'm not going to draw this on the board, but I'm going to hold this up and see if you're able to discern this. So the example the author has in the book is that you're going to prepare for an exam. And so the individual note cards are things such as get the CQE primer, other resource books, bonus, motivation, attend refresher courses, video presentations, study intensely, get rest, etc. So what you do is you take all of these individual note cards with those items listed on them, and then you group them into basic areas. So you have resources such as your study guide, you have motivation, you have how do you obtain knowledge and the preparation. So as this would relate to the manufacturing environment is that you would have a series of individual cards, and then you would group those together to determine the affinity of all those individual pieces. And then you would look at those like clumps or groups and then draw boundaries around those. So it's a way to take a more complex problem and bring it into a smaller group. Any questions about how to do the affinity diagram? So it's basically grouping by association of those individual pieces. Okay, the next one we're going to do is a tree diagram. And this is similar to some other things that we've talked about, such as the House of Quality. So the way to do this is you start with a goal or basic function, and you're going to have a second level. And I'm going to call them sub-levels. And the question mark meaning we're going to ask these questions each time. So one way to illustrate that is, let's just do a tree diagram. So what would be a good goal for a demonstration thing to write up? Anybody on the left side of the room throw out a topic of something to aspire to?
Engineering degree.
Or let's put on here leave room tonight.
Leave on.
That's going to be fast. All right, so what are some things that can help in with? So that's our goal, is to leave. And what means are there to make that happen? We can cover the material.
Fire alarm.
Oh, there you go.
Incapacitate instructor.
Just put leave. So does that make sense? So each level you go down, you restate the question of why and how. So if we're going to cover the material, that's our goal. What are the means? Well, we have 4 more topics to go through. Does that kind of make sense? So this is a tree diagram. Hopefully you recognize it. You start with the trunk and then you branch out into all of those. Next one we will do, I knew nothing about until I tried to take the exam, and because one of the questions had something like that listed in the question. I don't know if Jeff remembers that or not, but so I thankfully had my indexed book to refer to. So this is a process decision program chart.
So Jerry, to piggyback what you just said, the only way I was able to pass my CQE exam was by putting the tabs on the primer, because without it, no rule table of contents, getting those key phrases of the questions during the exam and being able to find them, that made all the difference in the world.
And as part of that test-taking improvement, having looked at the tabs previously help a lot. So in other words, I've seen some people that go into the exam and they have their book and they know that it's helpful, but they've not actually looked at it. And the reason I'm saying that is that the book is not necessarily obvious on where to find things on certain topics if you haven't looked for it before. So basic statistics covers things like central tendency, etc. But it's advanced statistics is where you find things such as hypothesis tests. So, good. All right, so let's finish this part up of a process decision chart. So basically, the way this, it's a graphic method. And the way I've understood it is it's you can either do a forward sequence or backwards. But let's start with the forward one. Let's use the example that they have here. I'm going to show the 2 different ones on the 2 different graphics. So one of them is you start with the goal. letter B one, and then you keep branching back to get to that. So you have your start goal, and then as you proceed through this, what is required to get there? So it's kind of another way of looking at it. Or the other one is you can start with, I'm just going to call it the beginning, and let's use their example they have here in their book. So if you're going to, if your supervisor says you have to pass the CQE in order to maintain your employment, what are two things you can do for that? You can take the CQE refresher courses or self-study. This will be with the class. Down here, you're going to have to get a book, do the problems. Does that kind of make sense? So the goal of many of these 7 that we're going to be going over today are just pictorial ways to take complex problems and communicate those to others in your organization. All right, the next one is a matrix. So this is going to be showing relationships between objectives, causes, etc. All right, so there's trying to decide how much depth we need to go into this. Let's just show a picture here. So this is an L-shaped one I'm going to show you first. BOK stands for Body of Knowledge. So we have quality management concepts. That was our first section in our book. Let's say we have our A, basic stats. All right, so what this matrix is telling us is that for the quality management, maybe you have some type of some experience with that at work, and you feel pretty, we'll say the solid means you got that topic really well. That kind of makes sense. I'll do that. So that's an L-shaped. It's given by its, if you turn it on its side, it's the letter L. You can also have a T matrix. In that case, you put your things of interest in the center and then along one row. That kind of makes sense. So you start with your intersection by labeling your center column and row. And then your matrix will be filled in those intersection points in the 4 quadrants. That is a matrix. Next one we're going to do is an interrelationship diagraph. This goes by the initials ID. Sometimes you see these in kind of crazy representations. I'm not going to label all of these, but All right, so the key thing with this is that you're looking at the interrelationship of each of these nodes, but it is not a network diagram as you would see in a moment we're going to talk about. So they're just showing how the nodes, and each node would be something about like the CQE exam is related to, you have to be signed up for that before you can take it. I may have my arrow pointing the wrong direction here. That kind of makes sense. So that is an interrelationship. You can also do prioritization matrices, which are basically just a way of a degree of correlation. And then the last one I'm going to mention is activity network. What topic, for those of you scoring in your books, did we already cover this once before? If yes, when? This is a terrible example, but I'll draw a picture and see if anyone recognizes. All right, so the activity network is a project management technique. So activity network, the Japanese call it the arrow diagram, which makes sense when we draw that. So basically it's a way to manage your projects for lead times and critical path. In my opinion, this is a over redundancy of calling this a different tool than we already had in a previous chapter. But one of the challenges that you often encounter with bodies of knowledge is that there may be a tool that's under use under a different name. All right, so my decision for tonight was we're not going to do our in-class activities, but I'm going to write it on the board and I'll post the assignment on D2L as well. And here's what I'd like you to do is to let's say I'd like 3 examples or implementations of those 7 quality tools. You can choose whichever the 3 styles to do. Does that kind of make sense to everybody? So let's just list those 7 verbally. We have check sheets, scatter charts, histograms, Paretos, flow charts, cause effect, and control charts. I would estimate that most of you will probably not do the control chart because we haven't covered it yet, but you can if you want. Does everybody feel comfortable on what I'm asking for on that? Any questions? This has been the quietest group today. What do we need to do next time to make it more lively?
Quit bringing a light.
All right, so